Ever had one of those moments where you have this crystal clear picture in your head, but you just can't quite draw it or describe it perfectly?
Oh, definitely.
What if you could just tell a computer what you're seeing and it just appeared instantly? That's the kind of fascinating territory we're exploring today.
Precisely. We're diving into Lumina-Image 2.0, which is a new framework for what's called text-to-image generation.
Text to image. Okay, so for those of us who aren't like fluent in text speak, imagine you're describing something wild. Maybe a corgi astronaut floating in a sea of donuts.
Right, a classic.
This technology, it acts like an unbelievably skilled digital artist who just takes your words and paints that exact scene. It's pretty cool.
It really is. And the research paper introducing Lumina-Image 2.0, that's our main source material for this deep dive.
Yeah, our guidebook. And our goal today, our mission, is really to figure out what's the most valuable piece of this tech, the key innovation, and maybe how these ideas could actually be useful for you listening right now.
Wow.
Even if you've never thought about asking a computer to draw, well, a donut cosmos.
Exactly. How does it translate to real-world use, even outside of, hardcore AI development?
Okay, let's unpack this. Lumina-Image 2.0. At its core, what's the really clever bit? How does
Right.
it work?
Well, at its heart, it's a system that turns text into images, like you said. The researchers built it around two core ideas. The first one is unification.
Unification, okay.
Think of it as like creating a single super smart brain, they call it Unified Next-DiT, that understands both the words you type and the visual bits of an image together at the same time.
So they're not separate things anymore.
Exactly. They interact seamlessly, like they're having a conversation inside the system. And this brain, it also has a special built-in caption writer, UniCap. Yeah, UniCap. Its job is to make sure the training data, the text descriptions used to teach the system are really, really good, accurate and detailed.
Ah, so it's like making sure our digital art teacher has the absolute best lesson plans. Got it. And the second key idea.
The second one is efficiency. Lumina-Image 2.0 is designed to be, well, faster and use fewer computer resources compared to maybe some older, huge model.
Right. More bang for your buck, basically.
Kind of. The paper mentions it uses about 2.6 billion parameters.
Wow.
Now, that might sound like a lot, but in the world of these big AI models, some have had, tens or even hundreds of billions.
Whoa. Okay, so 2.6 is relatively lean then.
It's lean for the quality it achieves, yeah.
Yeah.
It highlights how efficient the actual design, the architecture is, and importantly, the creators have actually shared their work publicly on GitHub.
Oh, that's great. Open source.
Seems like it, yeah.
Yeah.
Which is always good for the community.
Absolutely. Now, Unified Next-DiT, that sounds like the real engine behind that unification idea. Would you say that's maybe the most valuable technology in this paper, the core innovation?
I think it's very likely, yeah. The central breakthrough really seems to be this Unified Next-DiT architecture.
And why is that such a big deal compared to, like, older methods?
Well, think about how older systems often worked. Many treated text and images almost separately. They'd process the text, process the image, and then try to connect them using a technique often called cross-attention.
Cross-attention, okay.
Imagine trying to understand a joke told in two different languages, where you need a translation after every phrase. It can be slow, maybe a bit clunky, and some nuance might get lost.
Right, like trying to assemble IKEA furniture just by looking at the picture of the final product without the step-by-step bits.
Yeah, maybe a bit like that. What's really notable here is that Unified Next-DiT treats the text and image information as one continuous flow, like they're speaking the same language from the start.
Okay. No translation needed.
Pretty much. There isn't this separate back and forth trying to bridge two different kinds of data. This unification, it could be a really fundamental shift in how AI understands multimodal stuff. Stuff involving different types of data like text and visuals.
So instead of separate processing, it's more integrated understanding.
Exactly. And that could unlock totally new things beyond just making pictures. You mentioned an analogy earlier.
Oh, right, the recipe one. Yeah, imagine trying to follow a recipe. One way is you read the ingredients list, then you separately look at a picture of the finished cake. You can probably figure it out.
Sure, but it takes some mental gymnastics.
Right. Now, imagine a chef explaining each step while showing you exactly what the batter should look like, how the onion should be chopped right then. That direct, simultaneous explanation and visual, much clearer.
Absolutely. Much more intuitive.
Unified Next-DiT is more like that chef, processing the words and the visuals together directly.
That's a great way to put it.
Okay, that clicks. Now, the other part of unification was UniCap, the Unified Captioner. Why is having really, really good text descriptions so crucial for this whole thing?
Right, UniCap. Well, this is super important. Think back to that digital artist analogy.
Yeah, the super talented one.
The quality of your teaching materials, the examples, the instructions you give that artist, it massively impacts what they can learn and ultimately create.
Makes sense.
If you train the AI with vague descriptions or ones that are just plain wrong,
Yeah.
the images it generates are probably going to be, well, not great.
Garbage in, garbage out.
Correct. High-quality text descriptions act like precise blueprints, like really detailed instructions. They guide the image generator to make stuff that's accurate and looks good.
So it's like making sure our art teacher has a PhD in art history and can describe every brushstroke perfectly.
Precisely. And that's where UniCap comes in. It's a specialized tool the researchers built specifically to generate these excellent text descriptions for images. It's like having a hyper-observant, incredibly articulate scribe just dedicated to describing pictures.
Okay, so what makes UniCap so special? What can it actually do?
Well, what's really impressive is its range. First off, it's exceptionally good at understanding complex scenes. Not just listing objects, but figuring out how they all relate to each other in the picture.
Like the cat is on the table, not just cat, table.
Exactly. Spatial relationships. Second, it can generate detailed and consistent descriptions in multiple languages. The paper focuses on English and Chinese, which is what it was mainly trained on.
Okay, that's already impressive.
But here's the kicker. Because it's built on a powerful language model called Gemma, it also shows it can understand other languages. They mention German, Japanese, even Russian.
Wait. It understands Russian without being specifically taught Russian image captions. How does that even work?
It seems to tap into the underlying knowledge and patterns that the base Gemma model already learned across loads of text in different languages. It's sort of like if you understand the basics of French and Spanish, you can often puzzle out some Italian. Right?
Yeah, you can kind of get the gist.
UniCap leverages that existing linguistic understanding to interpret and describe images, even in languages it wasn't explicitly trained on for that specific task. It hints at a deeper understanding of meaning, which is pretty cool.
That's wild. Okay, what else makes UniCap stand out?
It can generate different styles of description, so you can get a really detailed paragraph or just a short summary, or even just a list of relevant keywords or tags.
Flexible.
Very. And it can do this from different angles, describing the artistic style, listing the objects, explaining how they're arranged, noting specific details like the fluffy gray cat.
Wow.
And another key thing, unlike some older tools that might shrink images down to save processing power, losing detail.
Yeah, making everything blurry.
Right. UniCap processes images at their original size, so it captures much finer details, leading to more accurate, nuanced captions.
Well, it's like having a super detailed multilingual art critic with amazing eyesight built right in, and the paper said it was better than other tools.
Yeah, they did some comparisons with tools like ChatGPT-4v and Florence. The examples in the paper suggest UniCap consistently produces more detailed and accurate descriptions. And better descriptions mean better training data.
Which means Lumina-Image 2.0 becomes a better image generator overall. It all connects.
Exactly. It's a virtuous cycle.
Okay, so we've got this unified brain understanding text and images together, and a super-powered caption writer feeding it top-notch descriptions. Now, let's get to the really interesting part for our listeners. How can you, the person listening right now, actually use this? How could it improve your work, your daily life, even if you're not, planning to become an AI art wizard?
Right. This is where it gets really practical and honestly pretty exciting. Think about everyday situations. Do you ever need a very specific image for, say, a presentation? Something that perfectly shows a complex idea.
All the time. Finding the right stock photo is a nightmare.
Exactly. Or maybe just a fun, quirky visual for social media that captures some random thought you had, like a flock of pigeons wearing tiny top hats having a serious meeting on a park bench.
Okay, I'd like to see that.
Lumina-Image 2.0, because it has this better understanding and was trained on such detailed stuff, could potentially bring those super specific, maybe even slightly absurd ideas to life much more accurately and quickly than older systems could.
So no more endless scrolling through stock photo sites hoping to find something that's just close.
Hopefully much less of it. And
Yeah.
think about people who, don't have graphic design skills. This kind of tech could be a total game changer for visual communication.
How so?
Imagine creating professional-looking visuals for reports, class projects, personal websites, whatever, just by describing what you need in plain English. It really lowers the barrier.
Hmm.
Anyone could potentially create compelling visuals.
That could be huge for so many people. Small businesses, students, educators. What other ways could this be practically used?
Well, consider learning. If you're studying, say, a historical event, imagine generating a visual based on descriptions from that period. It could make history feel much more alive, more memorable.
Yeah, much more engaging than just text.
Or for brainstorming. Even if you can't draw a stick figure, you could explore visual concepts, test out ideas, bring imaginative scenarios to life. It's like having an instant visual brainstorming partner. A superpower for your imagination, like you said earlier.
It really does sound like that. Now, okay, let's be real. The paper did mention limitations, right? It's not actual magic just yet.
That's a really crucial point, yeah. It's amazing, but it's still developing. The researchers are upfront that Lumina-Image 2.0 can sometimes struggle.
With what kinds of things?
Really intricate structures, like maybe complex machinery or very specific human anatomy poses. Also, really unusual or rare concepts that probably weren't in the training data much good. You know, that very specific type of 18th century clockwork bird you had in mind.
Okay, maybe not that specific yet.
Probably not perfectly. It could also have trouble with super detailed textures in busy scenes or rendering long, complex sentences as text within the image itself.
Ah, okay. So you might still get that three-legged pigeon in a top hat sometimes.
Possibly. Or maybe the text on a sign looks a bit wonky. It's not flawless, but the progress is just staggering. Room for happy little accidents, as you said.
Definitely. Now, this unified approach, the Unified Next-DiT, it sounds complicated. Can we break down how that magic happens in a simpler way, maybe with that party analogy?
Let's try. So remember we said it treats text and images as one combined stream? A key mechanism is something called joint self-attention.
Joint self-attention, right.
Okay, the party analogy.
Yeah.
Instead of the text words and the image parts having awkward separate chats across the room.
Shouting across the dance floor?
Yeah. They're now all mingling together at the same party, having direct conversations. They can both pay attention to what the other is saying and figure out how they relate, right there and then.
So less like a game of telephone, more like a really good group chat where everyone sees everything?
Exactly. This direct interaction lets the model learn the connections, the relationships between words and visuals much more effectively.
Okay, that makes sense.
And the paper also mentions multimodal rope, or M-rope.
MROE. What's that?
Think of it as the model having a special sense of where everything is at the party and how much space it takes up. It knows the donut word relates to the donut shape and roughly where that donut should be relative to the corgi and how big it should be. It understands position and scale for both words and pixels together.
Ah, okay, so it's like the seating chart and the room layout combined for both the words and the pictures.
Kinda, yeah. And remember, initially, the raw text info and the raw image info are quite different, like guests arriving in, I don't know, a limo versus a bicycle.
Very different modes of transport.
Right. So before they can really mingle effectively at the party, the model uses special text and image processors.
Oh.
These basically get everyone into a more similar party attire, the common format, making it much easier for them to interact using that joint self-attention.
Okay, got it. They need the right dress code to chat properly. That actually makes a weird kind of sense.
Glad the analogy worked.
Now, another thing that seemed really interesting, maybe even counterintuitive, was that longer captions actually led to better results during training. Wouldn't shorter, simpler instructions be easier for an AI?
Yeah, that finding is fascinating, isn't it? It turns out that longer, more detailed captions actually help the model learn more effectively.
How?
The researchers suggest that the attention operation, how the model focuses on different parts of the text and image, can act like something called a dynamic feed-forward network, or FFN.
A dynamic FFN. Sounds technical.
Think of it like the model's knowledge processing part. Its brain power essentially can actually grow or shrink dynamically, depending on how detailed the instructions, the captions are.
So longer captions give it more temporary brain power.
Kind of. It's like the model can temporarily expand its capacity to understand nuance and detail when it's given more thorough guidance. It doesn't actually add more permanent connections, but it utilizes its existing structure more deeply or effectively when processing richer input.
Whoa, that's really clever. So it scales its effort based on the input complexity.
That seems to be the idea. The paper even describes it mathematically, showing it's similar to scaling up the model's capabilities, but without the computational cost of actually making the model permanently bigger.
Okay, that's a neat trick. And the takeaway for us as potential users in the future.
It means the more descriptive you are in your prompts, The more detail you provide, the better and more accurate the images are likely to be.
Be a good director for your digital artist.
Exactly. Be specific, be detailed. It helps the model use its full potential.
Got it. Okay, efficiency was the other big pillar. We mentioned it's faster, uses fewer resources. How are they achieving that? We all want our images, like yesterday.
Totally. They use several smart techniques. One is multi-stage progressive training.
Progressive training.
Yeah, imagine learning to draw. You don't start with a photorealistic masterpiece, right? You start with basic shapes outlines.
Stick figures, maybe?
Right. Then you gradually add detail, shading, color in later stages. This model learns similarly. It starts training on lower resolution images to get the basics, then moves to higher resolutions to add complexity and fine details.
Building up its skills step by step. Makes sense.
Exactly. Then they also use these methods called CFG renormalization and CFG truncation. These are clever ways to streamline the actual image generation process itself.
CFG. What do those do in simple terms?
Okay, think of CFG classifier-free guidance as how strongly the model sticks to your text prompt. CFG renormalization helps keep the generation stable and high quality even when you're guiding it very strongly with a specific prompt. CFG truncation recognizes that your text prompt is most important early on when setting the basic scene. Later, as it fills in details, it can rely a bit less heavily on the text, making those later stages faster.
Ah, so it's like a painter focusing energy on the main subject first, then maybe being a bit quicker with the background details. Focusing effort where it counts most at each stage.
That's a good way to think about it, yeah. Prioritizing effectively.
Are there other speed-up tricks they mentioned?
They did explore others, like something called FDPM and Tcache.
Yeah.
But they found these currently had some downsides, maybe making the process less reliable or hurting the image quality.
Okay, so it's a trade-off.
It often is. Finding that perfect balance between speed, quality, and stability is a big part of ongoing research in this field.
Okay, so they're pushing boundaries on quality and speed, but still refining things. Here's where it gets really interesting. Let's try and boil this down. What are the absolute key takeaways from all this for someone listening?
Okay, summarizing. Lumina-Image 2.0 is a really significant step forward. Its main strength is how it understands and combines words and pictures much more effectively. That leads to better images, and it's more efficient.
And the keys to that are?
That unified architecture, Unified Next-DiT, treating text and images as one integrated thing.
Oh.
And crucially, using much better training data thanks to that super captioner, UniCap. Those seem to be the core innovations.
So it's not just faster image making. The AI actually has a deeper grasp of what we're asking for.
Exactly. It's about understanding intent better. And that improved understanding has a direct impact on you, the listener.
How so? Remind us.
Well, it gives you the power to visualize your ideas faster and more accurately. It lets you communicate visually, even if you're not a designer. You make learning more engaging. It really fuels creativity, letting you bring imaginative scenes to life.
It really does sound like it's democratizing visual creation, turning anyone into a potential digital artist, or at least a director.
That's a great way to put it, but as we discussed,
it's still evolving, still a work in progress.
Absolutely. Important to remember the limitations, complex stuff, rare concepts, maybe fine textures or text still give it trouble sometimes, but the progress is incredibly fast.
So what does this all mean? Here's something to think about. Consider the implications if you could instantly visualize any thought, any idea, complex or simple. How might that fundamentally change the way you work, the way you learn, maybe even the way you dream?
That's a really profound thought. The potential impact is huge.
Definitely something to chew on.